Alright guys, so this is a video that I promised I would make, and this is the one that we are going to go over a couple questions on if statements, else if, and just else. The first thing we're going to do is I'm going to show you the questions that I'm going to pick from. So a lot of these are the same exact sort of type. So we are going to do, we're going to pick 3 of them. So I did 1, 3, and 5. Because 4 is basically the same as 3, except you have to just convert. So I just went with 1, 3, and 5. And so the first one, which we'll do in just a second, I will read it. It says, suppose the legal drinking age is 21 in your state. Write and test a function to determine whether a person is old enough to drink. If the user enters a negative age, use the error function to exit the function and return an error message. So, this is what I have. So this is I just did this, a few minutes ago, but essentially this is how I would start the question. So the first thing we have to do is we have to make an age input, right? Because we are querying the user for their name. So the first thing is that we have to ask them what their age. Sorry, we are asking them what their age is. So what is your age, right? So that is the first thing we do. And what this is going to do is it's going to ask them to input their age, right? So that's the first thing we would do. The second thing is we need to start our loop, right? Our if, else if, and else. So our first one we're going to do if, and so our condition. So the legal drinking age is obviously 21. So our condition is that we're going to select the condition that tells them they are free to drink, right? And this is a normal drinking age, not a Carbondale drinking age. So the first one, so it's if age, which is our input variable that we made at the top, if age is greater than or equal to 21, right? So that is the condition of being, a legal drinker, greater than or equal to 21. Then down here we can display, so that's the display command, we can display you are of legal drinking age, right? Whatever message you want to put there, right? Congrats, you made it this far, have a beer. So then the next one, that is one condition, right? Now we need to do one for if you are not of legal drinking age, which would be age is less than 21, okay? Or, and then we have to make an error message go for if you said something less than 0, because obviously that's not a real age. So the next thing we have to do is we have to do else if, right? So this is the next statement. So else if, we would say age is less than 21, right? Age is less than 21, and I'm just going to add this in, age is greater than 0, right? So essentially, if we are less than 21 but greater than 0, we will do this part, which is display, another thing, which is you are not of legal drinking age, right? So this is the second part, is that we have the next conditions, which is a bracketed 21 or a 20 or less than 20. So if you put 20.5, obviously you're not there yet either, but 20 all the way down until 0, right? And then we do the last one, and the last one is, you can do this a couple different ways. They said use the error function, but I did not use that. I just did else, because essentially if you are, the way I have it set up is that if you are greater than 21, you will be the legal drinking age. If you are less than 21 but greater than 0, you will be not of legal drinking age, right? Any other values you input here would be less than 0, and so I don't really have to say, this doesn't have to be specified less than 0. Now I understand you could probably, use, you could probably put in here, I'm 5.5 or I'm 21.5, but ages are just in round numbers, so that's how I decide the program could be used. And honestly, you could just put this here in round numbers, right? Or in whole numbers. In whole numbers. Here, you can just do that. What is your age? Please answer in whole numbers. So, like that. But it doesn't really matter too much, right? I mean, either way, this is still going to work, and I'll prove that in just a second. So we have else, which is the final condition. This is the last thing possible. So you will have display error, age not possible, right? I would assume, those conditions have set it up to where it does not work afterward. And then you put an end, right? So end is the last one. So let's see if this works. I'm going to have to save this because video practice 1. Let's try that. So it says video practice 1. What is your age? Please answer in whole numbers. So I'm going to put 26. You are of legal drinking age. It returned to me. Now let's do it again. What is your age? Please answer in whole numbers. Let's go 19. You are not of legal drinking age. Obviously 19. Like I said, normal drinking age, not Carbondale. And then the last one. What is your age? Please answer in whole numbers. Let's put -1. Putting -1 there gives me an error of age not possible, right? And just to prove it, I could also do 0. And you also get age not possible. So this right here does the program just fine. This is exactly what they wanted to, except that they asked to use the error command, and which we did go over in the notes. But whenever I did it live, like just by looking at it, I was like, okay, what do I have to do? This is what came to mind for me. And it works. It works just fine. And so I just, like that last part I kind of glazed over. I was like, I'm just going to do things how I would think to do them, and this is how I did it. And it works fine, right? And that's why I tested these odd values, these 0, -1. I tested all the brackets to make sure it fills in where it needs to be. So this one is good, and that is the first question on the practice. Now we move on. I'm going to go ahead and clear this. We move on to the next one. And so the next one, I'll put it on screen. It says, when a part is manufactured, the dimensions are usually specified with a tolerance. Assume that a certain part needs to be 5.4 centimeters long, plus or minus 0.1 centimeters. It says, write a function to determine whether a part is within these specifications. If the user enters a negative length, use the error function to exit the function and return an old message, or an error message. So all of these questions are very similar. But it just kind of gets you in the used to using these things, right? And so they are going to be very similar, and you should be able to figure this out fairly quickly. But what we need to do is we need to just start the same one like we did the last one, is that we did part is equal to input, and we need to ask the user what the length of the part is, right? So you would say enter the length of the part here, right? So that will hold the variable of part. Now we have to start the if statement once again. So we have if. So the first one was if it's between, so remember that, it was 5.4, but it was plus or minus 0.1. So the acceptable values, quote unquote, by their uncertainty is 5.3 and 5.5. Anywhere in between that is fine. But we also need to have something for when it is not that, right? When it is not, or if it's not even a real part. Like if you put 0, it obviously doesn't work. So this time we're going to put 0. We're going to do the first one, the error message in the front. So we're going to do if part is less than 0, right? So if the input is less than 0, this is what will happen. It will display the following. It will say, this is not a, valid part length, right? Whatever it is. And then you end. So you can have multiple loops, right? So, or not multiple loops, multiple if statements. So right here, I've closed it. I said, if the part is less than 0, you display that. So this is the first thing. But then you can start another one. This is just to show you that there are other ways to do this. You do not have to try and fit this all in one. And what most of the book examples do is that they section off the error message to its own part. They do if error message, the conditions for the error message, and then they give it to you. and then they end, right? And then they do another one. So then we have the next part, which is if, and this is another if statement, if part is, I don't know, let's say, so if part, so this is where we have to put in our conditions for a valid part length, right? So if the part is greater than 5.3, so it has to be between it. Let me make sure I have made sure that if it has to be between it or not, because if it has to be between it, then needs to be plus or minus. Okay, so it can be those. That's fine. That's fine. So it says if part is greater than or equal to 5.3, and so this is the and sign. If the part is greater than or equal to 5.3, and part is less than or equal to 5.5, then we display the following. This part is up to spec, right? It is the correct specification for us. And then we do the following, which is else. So remember, we need to have one for where it is not inside of the spec, right? It is now outside of it. We have the error message if it's less than 0, but we do not have one for if it is, just a normal length. Like let's say we say 5.8. If it's 5.8, it doesn't work, so we have to say something, right? So we have else. I guess you could do else here. You could do else if. So else if. We will have part is greater than 5.3, or no, less than 5.3, sorry. If part is less than 5.3, or part is greater than 5.5. So essentially what this is reading as is that if the part is less than 5.3, or the part is greater than 5.5, it will do the following, and it will display this part is not up to spec, right? Whatever you want to put in there. And then, of course, you always have to end, right? The end is the important part at the very end, so we have to do that. So let's see if this runs. I know I have to save it again, so this is video practice 2, right? So enter the length of the part here. So let's start with the perfect one, the one right in the middle. So if you put 5.4, you get this part is up to spec because that is the exact middle of the inequality, right? Greater than 5.3, less than 5.5, right? Or equal to, sorry. Now we have to check the outer values. So I'm going to check those. 5.5. You get this part is up to spec, which is good because that's inside of the tolerance. And likewise, when you do 5.3, you get this part is also up to spec. Now let's do another one. Let's say this is 5.1. This part is not up to spec is what you get out of it because we are outside of this inequality, right? We are now outside of our range of acceptable, engineering values, right? And so we get that. And then, as usual, you test the error message that I put in. Let's say it is negative 20. You get this part is not a valid part length. This part is not up to spec. So actually, if what I could have done is that you could have had this stop at 0. But this still makes sense, though, right? This part is not a valid part length. This part is not up to spec. Clearly, those two conditions are met. But if you wanted to section this off differently, what you could have done is you could have had this be else if part is less than, if it's greater than 0, but less than 5.3, you say this message, and then or if it is greater than 5.5, you would get another message, right? Or you would get that same message. So you could have conditioned it to where 0 and less than 0 are all in their own bracket for a valid part length, but either way it still works. The function is exactly what you intended it to do. It intended you to tell you whether it worked, if it didn't, or if it was a valid part length. And like I said, this is just all things that I did when I looked at the question, right? This is my exact work, so I got it to work doing this. But like I said, I'm more my expectation is that you guys can know the functions like this, like you can know how to do this right here, and you can get an end result however you see fit to do it. If if your code, now there's obviously an optimal way to do things, but if you can do things and it's comfortable for you, and it gets the same result as somebody else, I don't see why that's a problem. So alright, so then we have the last one. I'm going to clear the command window. We have one more. And the last one is this rocket one. So you know how I love the rocket questions, right? So it says, many solid fuel rocket engines consist of 3 stages. Once the first stage burns out, it separates from the missile and the second stage lights. Then the second stage burns and separates, and then the third stage lights. Finally, once the third stage burns out, it also separates from the missile. Assume that the following data approximately represent the times at which the stage burns. So from stage 1, 0 to 100, stage 2, 100 to 170, stage 3, 170 to 260. Write and test a function to determine whether the missile is in stage 1, stage 2, stage 3, or free flight, which is after stage 3. If the enter uses their negative time, use the error function to exit, right? So, no big deal. Alright. So, just like last time, we have to ask something of the user, right? So I'm going to call this time, right? It could be whatever you want, rocket time, but I'm going to call it time. So we have inputs of time. I guess you would say enter the flight time for the, I'm going to call it SFR, which is the solid fuel rocket. But whatever you guys want to call it, you can write whatever you want in there, essentially. Enter the time for the enter the flight time for the SFR. So time is now saved as a variable for them. And like the last question, I'm going to separate the error part before everything else. So we're going to do if time is less than 0, right? If time is less than 0, we display the following. This is not a possible time, right? Because obviously if we're looking at a flight time and we are less than 0, we haven't even it's not even taking off. It's not even at the point right before. So it doesn't make sense, right? So then we end, right? Now we have to do the next one. So if the next statement is the first condition, so it's 0 to 100 is the first stage of the rocket, right? So if time is, we will say, greater than or equal to 0, right? If time is greater than or equal to 0 and time is less than 100, right? Because, so this one, like I said, is kind of confusing, is because the ends of them are actually included in both. So time is included in the first stage, so 100 is included as a first stage and a second stage. So I'm just going to do time is less than 100 because I assume right as 100 hits, we move on to the second stage. So that is my assumption, but if it isn't the case, you could very quickly change these like to greater than or equal to, but it works out. I tested at the end, so we have if time is greater than or equal to 0, we then display, and also less than 100, we display the following. We display this rocket is in stage 1, right? With those conditions, we are in stage 1. Now we have else if time is this might actually, yeah, I'll do it this way. Never mind. If time is greater than or equal to 100, and so I kind of caught myself there because I was actually going to program in, if I didn't add this equal sign, 100 wouldn't have returned a value because I have values of less than 100 and it would have been greater than 100, which means 100 wouldn't have returned anything. So you do have to be careful. I caught myself. I was about to do that. Else if time is greater than or equal to 100 and time is less than 170, which was 170 seconds, which is the second stage, right? And then we display this rocket is in stage 2, right? And then we also have else if time, so this is the last stage, the third stage. If the time is less than 260, right? And remember, if it doesn't fit into this criteria, it will move on to the next one. So every value that doesn't fit into this criteria, so essentially it's between 170 and 260. So else if time is less than 260, then you display this rocket is in stage 3, right? And now there's one more thing we have to do before we end it. So after 260, it is now in free flight, right? Because there's no more jets, or there's no solid fuel rocket boosters anymore. It's off on its own power. So we have else. So this is all other values, right? This is everything else that has not been defined here. Else, we display this rocket is in free flight, right? Which is the last stage, I guess. And then, as usual, you end right afterward. I'm going to have to go ahead and save this again. So then we have, let's go, I guess we could do video practice 3.